Alright guys, welcome to another update video on my RC Submarine project. So here I've got my U-boat sitting on one of my workbenches on a piece of wood so that I know the keel and the whole hull is actually completely leveled out. I know the last time we left off I was going to cut off this top deck portion of the center section so that I can gain access to the previous pressure hull in there to punch some holes into that ABS tubing to let water flow in and out during diving and surfacing. But I figured that since all my existing mounting points are intact right now, this will be a good opportunity for me to actually set up or size up rather my watertight cylinder. That's a 3-inch Lexan or polycarbonate piece of tubing. When I actually built this hull a few years ago, the way I had it mounted, the way I had the 3 main sections mounted was I installed these aluminum bolts, one here and one at the back there, so that I can pass through these aluminum wing nuts to secure the stern and bow section to the center section during construction. And those bolts have proven again to be very useful at this stage, because if I secure them again with these wing nuts, I know that my hull is perfectly aligned, so then I can come in and measure my watertight cylinder. So on the topic of watertight cylinders, I actually started laying out the components that are going to go inside this clear piece of tubing. And that's what we're gonna go cover next. So I'll move to another one of my workshop tables to show you what I have in store. All right, so just want to show you some of the parts that I designed and 3D printed so far that are gonna go in the watertight cylinder. So first off, we have the stern end cap of the cylinder, and you can already see that there's 2 ball bearings seated in there, and of course those are going to be for the 2 main drive shafts. They're going to go through this end cap and out the back. And if I turn this around, you can see that there is a U-shaped brace that's already attached to this end cap. And what those are is, I'm not sure if you can already guess that, but they are actually for the rudder and diving plane servo, rather the stern diving plane servo that are going to go on this end cap. And these look like your run-of-the-mill standard size servos, but they're actually a size smaller. They are what's called a mini size servo, so in between a standard size and a micro size. And I feel that for the size of the boat that I am building, given the weight of all the ballast that's going to be in there and all the batteries, this will be more than enough to actuate my control surfaces. So you can see that on this end cap there's some holes there for the mounting bolts that are going to go into the servos there on the side. And if I turn this around, you can see that there are some holes there for the prop shaft seals rather, and those I've elected to use. These are called SIMMERRING seals, and they are basically a very fancy type of cup seal that are used to seal rotating shafts against oil or water. And they have, I don't think the camera can zoom in all the way, but it is just a piece of rubber that tightens very closely to the drive shaft, and just have to make sure that this is oiled properly to ensure a smooth running operation. Okay, so before getting to the rest of the parts, I just wanted to show you guys a neat little servo setup that I've got going on here. And this is basically my rudder servo that's now sitting in the servo bracket that you see here. And you notice that the servo horn looks a little distinctive. And the reason I have it set up like this is because I wanted to run a linear servo system to control my rudder and rear diving planes. And the way I've done this is using a standard length of brass rod. This rod is my rudder linkage. I'll have another rod on the other side for my diving plane linkage. This linkage is actually sitting in this ABS tube that's right there, and it's constrained to move only along one axis. So it doesn't have any wobble that you see in some of the other system. And on the other end of this linkage is the modified servo horn. And the way I've done this is I've basically taken a standard servo horn and I've cut a slot with my hobby saw and filed that into the right, I guess, the right gap thickness. And that slot is where those standard servo linkage mounting holes would be. And this fits right onto my servo, you see here. And I have the servo hooked up to my ESC, which is sitting right outside the camera frame. And just by moving my transmitter stick, you guys can see that now because of that slot in the servo horn, this is allowing the linkage to move in a, I guess, somewhat a linear fashion. So the reason I like this system is because it allows me to mount the servo relatively close to the ENDCAP, and you see why later on when I show you the motor compartment. But so yeah, just I thought about using 3D printing some gears and rack and pinion setup to have a linear servo setup, but so far this is the system that I found to be the easiest to achieve using just your standard servo accessories that come with every servo. So next up we have the motor section, and this is pretty self-explanatory. What I have here are 480 size motors, and those were originally from an RC tank gearbox. And given the size of and the weight of those RC tank models, these motors are actually meant to carry a lot of weight, and they're very, very powerful. Shouldn't be short of torque. But to reduce the speed of the pinion there, I have two planetary gearboxes. These are the same type of gearboxes that are used on my 196 scale blueback submarine. And you can see that this is mounted to a rather thick motor mounting plate. Now you might notice that there are a lot of holes there going at the top half of that plate, and I'll explain to you why very shortly. The two middle slots there are the vertical slots that you see here and here. These two are for the wires belonging to the rudder and diving plane servo, and essentially this whole assembly slots into the bearings. Yep, my servo's flying off. It slots into the bearings that are on the stern and end cap there. So you'll go through like this, and you notice that there's also a lot of holes there on the end cap. The reason I have that, as I'll explain, is because I want to use these threaded rods, and these are going to be going through this motor plate, and will come to meet the hole that's going to be in the stern and end cap. And what this will create is, as I build up the sections one by one, there's going to be basically three threaded rods that are going to run through the whole watertight cylinder, and those three threaded rods are going to add a lot of rigidity and allows me to have a whole rack system going on there, so whereby I can simply pull out their rear end cap, and the entire electronic rack with everything secured is going to come out in one piece. Now on top of the motors is a standard Dean's plug that's going to go into the ESC, which leads to the next component that I'll show you, which is the ESC mounting plate. Okay, so this is the mounting plate for the ESC, and you can see there are the same three holes that are going to match up with the holes on the rest of the system there for those threaded rods to go through. Just to explain some of the features on this part, I got a large plate there so I can mount my ESC here, and on the other side I've got the two little slots there for the servo wires to go through. And this whole system mounts right through the motor section. And hard to do this with one hand, but essentially this motor plug would come through this hole there that you see there in the middle, and the whole assembly basically sits on top of that. So this is the parts that I have so far, and we're gonna move slowly, through to the bow. And the next thing that's gonna be designed is going to be the ballast tank that's gonna be sitting on the other end of this plate here. And you can see that there is a large circle there, so that I can run my wires through to the bow section of the boat. All right, so here we have the drive unit completely assembled. And I must say, guys, I really like how this turned out. Everything sits in there quite nicely. And you've noticed that towards the stern, I put on the 2 rubber bellows that are seating the aft linkages. And the reason I went with rubber bellows instead of using O-ring type seals is simply because I just happen to have a lot of these parts on hand from years of me collecting, RC boat parts. So, and the rubber bellows seal linkages very nicely. I haven't had any problems on my other watertight cylinders so far. So we're gonna stick with those for the time being. And you notice that on the bottom there, I haven't put on my prop shaft seating prop shaft seals, simply because I will be testing the driveline once I mount this whole cylinder into my U-boat. So I figured it would be better to mount those prop shaft seals once everything is top shape and I don't have any kinks in the driveline, since in dry dock or on dry land I want to run the motors without the prop shafts as much as possible, so that I don't wear the rubber in these SIMMERRINGs down too much. And tip for you guys, if you ever do want to run your motors with the prop shafts seals in place, make sure that you lubricate them with the silicone or lithium grease, so that you don't cause any unnecessary wear on the rubber there. So that's that. I can see that the 2 servos are there sitting there very nicely. I made sure that the hex screws that are holding down the servos in place are easily accessible via a standard hex key. And you can also see that the threaded rod that runs, actually 3 threaded rods that run through the length of this section are also secured in place. I'm using some thread lock there to lock both sides of each plate with these nuts, so that it's preventing any slippage from happening. And I quite like this setup because just from holding this, it's quite a hefty system, and I really like the robustness that the design gives. Towards the bow here, you notice that this is the space that I left for the ESC. I'm using the M-Tronics Viper Sub 10 ESC. It's good for, I think, batteries of 6 volts all the way up to 12 volts. So it should be more than enough for me to run my U-boat. And this fits very nicely inside this compartment. I just don't have it mounted because I do want to test this with the batteries hooked up. And for now, it's a lot easier to do that with the ESC not sitting in the cylinder. So this is about it for this part of the build. Next up, I will get my cylinder tube cut into the right length, so then I can move, as I said before, move along to the bow section where I can tackle the ballast tank and the pump, the valve, the receiver space, and the bow servo space next. So hopefully you enjoyed this little update. Stay tuned for more videos to come as I chug along very slowly on this U-boat build. So thanks you for watching again. Make sure that you like and subscribe for more RC submarine content, and we will see you very, very soon. Take care.